In this video, we're going to talk about power sets, which are a class of sets that are built from other sets. And one of the main concepts here is that we can have sets whose elements themselves are sets. So what is a power set? A power set of a set A is the set of all the possible subsets of A. Okay, let's have a look at an example. So A now is going to be the set of all countries in Great Britain. So A contains England, Scotland and Wales. What would the power set of A be? The power set of A, and we denote it by this symbol here, P bracket A. That is going to be a set, so we're going to list all its elements with curly brackets now. And its elements are going to be all the possible subsets of A. Let's do this systematically. What are the subsets of A which only have one element in them? Well, you could have the set that just contains England, the set that just contains Scotland, and the set that just contains Wales. We can also list all the subsets with two elements in them. The set England and Scotland is a subset of A, the set England and Wales is a subset of A, and the set Scotland and Wales is a subset of A. There's also the set that contains three elements, England, Scotland and Wales. Now that is just A itself, but we've mentioned before A is a subset of itself because all the elements of A are contained within A. And the last thing we talked about in the previous video was that the empty set is a subset of all other sets. So these are all the possible subsets of A, and if we put all these in a set, we can call this the power set of A. And the power set of A and A are two different sets, just one is built from the other. Are these useful? These do have some applications in computer science, but I'll be honest, these don't have that much uses, but they are a good way of introducing sets whose elements themselves are sets, as you can see here. But they do crop up now and again. So for example, imagine we had a car boot sale. We are selling four things. Let B be the set of all items that we sell at a car boot sale. And we are selling a doll, a hammer, a cardigan and a ring. What is the set of all possible different purchases that could have happened at this car boot sale? Well, again, that is all the possible subsets of B, because you can only buy a subset of B. So you could have bought just a doll. You could have bought just a hammer, just a cardigan, or just a ring. You could have bought a doll and a hammer together, a doll and a cardigan together, a doll and a ring together, and so on. You could have bought three things, a doll, a hammer, a cardigan, a doll, a hammer, ring, and a doll, a cardigan, and a ring. You could have bought all the things, a doll, a hammer, a cardigan, and a ring. Or you could have bought nothing at all. So all the possible purchases that you could have done are all the possible subsets of what you're selling. So the power set of B, the set of things you're selling, is the set of all possible purchases. Power sets are built from other sets, so their properties will be related to the original set. And here's a relationship. So the size of the power set of A is equal to 2 to the power of the size of A. And this is actually where the name power set comes from. The size of the power set of A is equal to 2 to the power of the size of A. Let's have a look at the two examples we previously did. In this case, how many elements did A have? Well, the size of A was 3. How many elements did the power set of A have? Well, there was 3 ways of choosing just one of the countries. There was 3 ways of having sets of 2 of the countries. one way of having all three of the countries and one way of having none of the countries. So altogether there was 8 elements in the power set of A. 8 is 2 to the 3, 2 to the size of A. Let's look at the car boot sale example. So here we were selling 4 things. The size of the set B was 4. And how many things were in the power set of B? Well, there was 4 sets of 1 thing, 6 sets of 2 things, 4 sets of 3 things, 1 set of 1 thing, and 1 set of 0 things. There were 16 things altogether, and that is equal to 2 to the 4, 2 to the size of B.